Let's talk about what is a binary file. How do we create a binary file, write data into it, read data from that, and also perform either sequential access or random access using binary files. Now, binary files are typically the data files, and these are the files in which we store data. So we are talking about binary files. Now, let's assume we have some data in the memory. So this is a block of memory where we have information about, let's say, a product. So this is where we have the name of the product. This might be some 30 characters. And then the price of the product, which is, say, some 4 bytes. It's an integer, so we assume it occupies 4 bytes. So this is a block which contains the product name and price. Now I want this block to be written into a file. Not just one block, a bunch of blocks. So here is my file, and we call it as products.dat. We give the extension DAT to indicate it is a data file. Well, you can give any extension, but typically we give extension .dat. Now, this is the block of memory, and I want to write this block of 34 bytes straight into the file. So we are writing a block that is in memory into the file. And like this, we will be writing one block at a time. So your file is containing a bunch of blocks like this. So each block is of 34 bytes. And in each block, we have the name of the product, price, the name and price. So this is in C a structure, because if you want to have multiple attributes put together, you need to use a structure. So we are talking about struct product. We create a structure called product, and struct product is going to have 2 members. The first member is a string, which is declared like this. It can have up to 30 characters. That is the name of the product. The next one is the price, which is an integer. I assume the integer is occupying 4 bytes. So each block occupies 34 bytes in memory, and we want that to be written as it is into the file. So we have to create this binary file, and we need to write a block of memory into it. And like this, if you keep writing, you have a set of records. We can also call them as records. And each record represents one product with product name and price. Now, let's see how we implement it and what are the changes we have to make from typical file handling, and what are the new functions we need to use to write and subsequently to read. So a binary file is a collection of bytes, and if you open it in editor like Notepad, you don't see meaningful characters, because it's not like a text file, which is a collection of printable characters. Text file is a collection of printable characters, but binary file is just a collection of bytes, and those bytes can represent anything. So I need not have a collection of products. I may have collection of points. I may have collection of times. I may have collection of contacts. I can have anything. But as I know very clearly, each record is occupying exactly 34 bytes. If I'm interested in 4th record, I can directly jump to this particular point and read 34 bytes from there. This is possible in binary file. I can calculate to which position I need to go if I'm interested in fourth record, and then I just need to go there and read that particular block. And I know this block is of 34 bytes. So that is the way we need to do it. So let's go and first write blocks of memory into the file, and then we'll see how to read, and then we see how we can jump to a particular record and read that, which is of course known as random access. So the first step is to create structure. So this is about write details of products into products dot dat. Now hash include stdio.h as usual, and then create a structure called product, and in that structure we have name, which can go up to 30 characters, and price. Well, if you want to have a lot more details, you can. You may have quantity on hand, you can have description of this product, you can have a lot more details. But let's keep it simple. Now the next thing is we want to take data from user. Whatever data we take from user, we write into the file. To start with, we have to open the file, so we need to declare a file pointer. And we also need to create a structure. So struct product, that is the product. That is the variable. And let's open the file. The first thing is opening the file. So fp is equal to fopen in the current directory, products.dat, and then wb. This is very important. We must explicitly mention it is a binary file. B stands for binary. And if you don't give that, it assumes it's a text file. And text file is not a collection of raw bytes. It's a collection of characters, printable characters. So you should not open it as text file. So don't forget to give B. And as usual, we check whether the file is opened. If not, we need to stop the program. So printf, sorry, could not open file. That's it. You exit with some code other than 0, because 0 indicates successful termination, but this is not successful termination. What else? Now it's time to take data from user and write the data into the file. I want to take not just one record, one product details, but I want to take details of multiple products. So I go with something like while one. It's a never-ending loop, and we take the details. So to start with, I say I want to take product name. So we say product name, and then get is product dot name. We take the name, and we say if the product name is END, it means user wants to stop. So END to stop. So if user enters END as product name, it means user wants to stop. It doesn't want to enter details anymore. So we can use strcmp and then product.name comma END. And if it is 0, we are going to break. Otherwise, we ask for price. So printf enter product price. And then we take the value. %d ampersand product dot price. Okay, we got the required data, the name of the product and price. Now it is time to write this structure, the product, directly into the file. So we have to use a function called fwrite. Fwrite is the function used to write a block of memory of a specific size into the file. And it is going to take 4 different parameters. The first parameter is the starting address. And second one is the size, and then the number of blocks, and then the file pointer. So that is your F, right? So you can see we want to take data from the address of product. So that is the starting point. That is the address from where we have to take. But how many bytes you want to take? That is size of struct product. So whatever is the size of struct product, those many bytes we need to take. And we want to take only one block. So we give 1. And we want to write into FP. This is the file pointer. So starting from this address, take a block of this size. And we want only one block. So we give 1 as the number of blocks. And this is the target file pointer. That's it. And we need to go to the top and redo that. Again, take the details of another product. But you do have a problem whenever you use scanf and getf one after another. So it's always a good practice to clear the buffer after scanf. So before getf and after scanf, you need to clear the buffer. Well, you can do it here or you can do it there. So I say clear keyboard buffer by using f-flush of stdio. We have to clear the keyboard buffer. This is how we clear the keyboard buffer so that any pending characters in the keyboard buffer are removed and you will be able to read the product name. Otherwise, your scanf will be reading a number and it will leave that new line character in the buffer, and that will cause an issue with this getters. So make sure you flush the standard input stream so that anything in the keyboard buffer is clear. Well, at the end of all this, you must close the file as usual. This is the way you close it. That's it. That's the program. Let's go ahead and save it. And I'm going to put it in our folder, whatever it is. Okay, so we put it here, files, and I say write products.c. And it'll create a file with the name products.dat, and it'll open that in write mode and binary mode. So let's give it a try, run it. So it's asking for product name. So I say this is something like iPhone 11 and then some price, and then it's asking for one. And this time I'm saying something like Dell laptop. Okay, some model, doesn't matter. Okay. And then I'm saying 67,000. And then I'm talking about something like the monitor. We say something like Dell monitor. And you can also say 15 or 24 inches, whatever. We can have up to 30 characters. So this is what we give, and we are saying 15,000. That's it. I don't want to give any more. I can give END, press enter key, the program stops. So by the time the program stopped, you have already given 3 products and the data is written into this file. Now, if you try to open that file using any text editor, you don't see the data in the way you expect. But anyway, let's try to open it. So I would like to open that using some text editor. So let's go open. We go to the file, and then we are saying classroom. And then we open that file. So here is the file. Products.dat. It is associating that with some other product. I mean, some other program like VLC player. Well, it doesn't matter. You can just open it and this is what you see. Well, depending on your editor, you might be seeing data in any of these ways. And I'm using something like Sublime, which shows it in this way. But if you go to Notepad, you're going to see it slightly differently. Let's open this in Notepad. So again, let's go down. Now here it is expecting text files. So change it to all files. And then you go to product and open. This is what you see. So it's not a text file and you don't find the characters that are just printable characters. You find some funny, crazy characters because this is just a bit pattern in the memory that is directly dumped into the file. So you have some crazy characters because the bit pattern represents different ASCII codes, not anything that we are familiar with. So this is how it looks in the file. But anyway, we don't have to open it in this way and see it. But you know it is internally storing all the data. So it stores 3 records and each record of 34 bytes. It's going to occupy a total of 34 into 3. That's going to be 102 bytes. Okay, now this is about writing. How do we read? I want to read the same data. Okay, so let's go and save the same program with a different name, that is read products. Now, when you save that, we are talking about read products, read details of products from products.dat. Now, the structure should remain exactly the same. That's very important. The structure should remain exactly the same. And you cannot have anything else but this. And then we are talking about creating a variable of this struct product. Well, if you change the structure from writing to reading, you get invalid data because it should read exactly 34 bytes, nothing more, nothing less. So make sure you stick to the same structure. In fact, you can put the structure in a header file and include that header file into every program so that we use the same consistent structure in all programs. Now, this is where we have to change it to RB. We want to open the file in read mode and read binary. And then we do go for this and no flushing, nothing, because we are going to read nothing from user. We are instead reading one record at a time. So I'm going to say fread. And the syntax remains the same. And it is going to read one record and it returns the count. And the count indicates how many records it read. The count indicates how many records it read from the file. Of course, I'm asking for 1. And if it is not able to read that, it means we reached the end of the file. So if count is not equivalent to 1, if it is 0, it means we reached the end of the file, we come out. But if it is not 0, it means we could read something successfully and we are going to display the product name. So 30S and then something like maybe some 8D. That is how we print the data. And here we say product.name and product.price. So this is what I want to do. And at the end, you close the file. So read one record. If you don't find it, this means you reached EOF. If you reach the end of the file, you're going to break. And if not, you're going to print the details. Now you need to create one more variable, that is count. Now all should be fine. Go ahead and build it. Well, no errors. And if you go and run the program, you should see whatever we have. That's the data. Well, the product name is coming in a different way. I should give minus 30s to indicate I want left justification. Otherwise, it is right justifying the data. So we need to change that. Go ahead and do this. Now that's how you display the data. So you wrote the data into the file and you're able to read the data and display that. And you're displaying all the details of all the products. So you're reading every record that is present in the file, not just one. And this is, of course, sequential access because you go from top to bottom. And this is how it reads one record from the file. It will copy that into this product object. It's like this. This is your file. And you have a block of 34 bytes, and it is going to read that into a variable of a struct product. And this represents the address. Say the address is some 700. Now from here, whatever data we have, this is read into this block. And exactly every byte from this is read and written into this location. So 34 bytes to be precise, read from this, and those 34 bytes are written starting from this address, and that is nothing but the address of your product, that is struct product. So this is how we read one block and copy the block into memory, and we wrote the block in the previous program. Now we are reading the block and writing the block back into memory. And we keep reading one block at a time like this until we reach end of it. And right now we have only 3 blocks. So after reading the third block, we reached end of the file. So it is going to say, okay, you read 3, this is EOF, and it'll return 0. And we stop. So that is about how we can write and read using data files. And data files can be used to store any amount of data. Of course, nowadays we use databases and various other things. But there was a time these databases were not available. So people use it to depend on flat files. And these are all flat files, simple files, nothing else. Everything is stored in a flat file and manipulated. Even today, in spite of databases and all, for some purposes, we still prefer data files because they're pretty fast. You can very quickly access data and do all the required manipulations. You don't need to go through a database because database is generally a very hefty component. We can use flat file to store data, and you can write, read, and do all sorts of things. So this is the program 2, which is going to read data from a file, and it is reading all the records. But what if I want to read only one record? I want only third product or second product. If you have hundreds of products, you can mention any product that you want. It should be able to read and it should be able to display. Well, in that case, I don't want to go in this way. So what if you want to read details of only one product, not all the products? Then we need to apply what is known as random access. So when you're talking about random access, it's different. Okay, let's see that. So now let's understand how to deal with what is known as random access. So we are going to access the data that we specifically need, not the entire data. Well, random access is a very common thing when it comes to memory In fact, when we say RAM, it is random access memory, because your memory can be accessed randomly. It simply means you have the memory. I'm talking about your primary memory, also known as RAM. And I can go to any location in memory and read that byte. I don't need to start there and go all through this. I can jump to any location and read that particular byte. So if you can go to any location and pick up the data from that location, we know it as random access. Now, how do you do that random access in files? Well, here is my products file, and we have seen how to write into it or how to read. Now, a record in products file is occupying 34 bytes. So let's assume we have some records like this. Now, what if I want to read the third record of this products.dat? This is products.dat. What if I want to take the third record? Then I need to go in two ways. Number one, I can start with the first record, read this, read the second record, and when I come to third record, I say, yes, I got to the record I need to display or I need to read, and I stop. Like that, you can go to any record. You can go to 100th record or 657th record, anything you like. But that is called sequential access. You're just going record by record. It's too lengthy. If you have 10,000 records and if you have to go for 9,256th record, you have to read a lot. That's not faster. That's not efficient. So random access is where we are going to jump directly to that particular location and we start reading from that location. So I want third record. I know that this is my record. And I know to read the third record, I need to skip two records. I need to jump over two records. So if this is what we want, we subtract 1. That's going to give you 2. And then multiply this with the size of the record, that is 34. So if I can jump over 68 bytes, then I will be going to the record I'm interested in. So this is the record's number, subtract 1, because the first record is at position 0. So we need to subtract 1 from record position, multiply that with 34, and you get the number. And if you go to 68th byte, you will be going to the starting position of the record. Now this is where you need to go. This is the starting position, exactly this. Now what is the byte position? That is 68th byte. Actually 69th byte, the index is 68. So 68th index, but it is 69th byte. It's 68 because we are talking about 0 to 67 for first two records. So we need to jump to 68th byte. That means index 68. Actually, it is 69th byte. Please remember that. Don't get confused. When I say 68th, it is like the index. I'm referring to index. 68th index would mean 69th byte from the beginning. So this is the calculation. So if you generalize the calculation, we are talking about something like n, that is the position minus 1 multiplied by the size of the record. The size of the record. And this is going to give you the position where you need to go. And then you need to read a block from that position. From that position, I need to read a block. And I know it is a block of, again, 34 bytes. So this is random access. We jump to a particular location we read a block from that location. You can, in fact, even write if you want. It need not be reading. You can write on the top of an existing block. I mean, we can write a new product record with the new price and the name. So it is possible to update. It's possible to write a new record on the top of an existing record. But for now, let's just read the data. We don't have too much of data, but still it is possible to understand how to perform random access. So let's go and save this as get product. We call it as get product. And this is going to be the same details of a product based on position, based on record number. That is like position, record number is assumed to be the position. Now, what we need to do is we need to ask user to enter the position. So open the file in the same old read mode because we are reading the data from the file. And then we say we want to take the position. So product position. So enter record number. And we read it. Scanf position. This is nothing but the record number. And now we need to calculate what is the byte position, to which position you need to go. So we can make some minor changes here. You can ask for the exact position in the file to which you need to go. And from there, we can read one block. So we use something like fseek to do that. Fseek is saying it will go to a particular position in the file. It will take the pointer, the file pointer means from where you read or write, it will take the file pointer to a particular location. So I say FP, and now the calculation. The calculation is simple. As we discussed, position -1, okay, into size of struct product. And don't ever hard code the numbers. Don't say it's 34, because what if integer occupies only 2 bytes in a different platform? So always make things more maintainable. Give it in this way. And then you are saying you're going to go from the beginning. Seek set means from the beginning. This is one of the predefined constants. Seek set stands for from the beginning. So from the beginning of the file, I want to jump to this position. This is the position. And we already understood what is the calculation behind it. This is n-1 into size of record. Exactly the same calculation we are applying here. And after that, you read that line. And if that line is found, we are going to display. Well, let's not worry about any validations as of now. So we are just trying to move to the required position and read a block from there and print that block and close the file. Nothing great, nothing complex, it's simple. So we need to check whether the count is valid, but for now, we can go ahead and run. Now, if I say I want second record, it's giving me second record. So it's directly going to second record, which is a Dell laptop, and it's giving the details. Now run again, and this time if I say I want third record, it gives me Dell monitor. So that's the way you jump to a particular location in the file and you can read from that location. But what if I give the record that is not existing? What if the record is not existing? So you need to check whether we could read. If count is equal to 0, we have to say that this is not found. So printf, sorry, record not found, whatever you like. And then else you want to print. So let's see how it works. Let's go and try something like 3 again. It's working. But if you run and if you are giving something like 9, it says, sorry, record not found. Because you couldn't go to that location and read anything from that location. So it gives you a message saying, sorry, record not found. So this fseek is not successful. So this is the way you implement random access. And this is about position file pointer to the required location. Then you need to read a record. And if the record is successfully read, we display it, otherwise we don't. So that is about how you perform random access. So we understood how to write blocks which contain the data about products. And those blocks are written into binary file. Then we learned how to read. And then we understood how we can jump to a particular location, read only one block instead of reading everything. If you start reading everything from the beginning, we call that as sequential access, but this is known as random access. So what we did in this example is random access.